in 1993, the field of information science, information theory changed very much. And then this is also we get from the invention of low density parity check code in 2001. Actually, it was found by a doctor student, so it is actually found in a doctor thesis. So I hope that your doctor thesis will be like this too. So you can find a new technology, very innovative technology, and then even though that at the time, so in 2001, it was not recognized as a good technique because no one proved that it can achieve the sound limit. Because the computer at the time is not so very fast. And then they invented, this is actually in 1963, and then reinvented in 2001 because we have a very high-speed computer to prove that the coding works very well. Right? So the key point that we can learn from this is try to make your PhD thesis as best as you can. As best as you can. Even though that year no one can prove or no one can see your result, but maybe 10 years later or 20 years later, maybe someone will revisit your invention in your doctoral thesis. So don't write just easy doctoral thesis, but try your best to write a doctoral thesis. And then the keyword of the improvement in turbo code is actually this one. But you don't need to remember the test. Need the probability of y given x equal to 1 and probability of y given x equal to -1. It's the same thing as like this. Given the information that AISC conference is called, and then what is the probability that you will submit paper? Or given the information at AISC-T is bad, what is the probability that you will submit your paper? It's like that. So X is the a priori information. The information before you make decision. This is what is the meaning of this equation. Given that X is 1, what is probability of y? And then by doing this, you can guess. You can guess what you can give to your friend. For example, this is you are here and then your friend are here. So you have each other. Actually, this is what we learned from our religion actually. In our religion, it is said that if you pray, salat berjamaah, and then you can get 27 degrees or better reward. Actually, we found that in information theory. So we apply this. So we use the information from decoder 1 and then give to decoder 2. And then decoder 2 give to decoder 1, and then we do this iteratively. By assuming that each decoder does not tell the lie. So the keyword if you want to do cooperation is don't tell lie. What is the meaning of lying? So given the probability of something and then because he makes decision based on your input, and then if your input is wrong and then his decision also wrong. And then if this is wrong, give to this and this is also wrong. This is what we mean by decreasing in exit chart. If you have or you evaluate the coding theory and then the exit chart is going down, it means that your coding is wrong. It's very easy to understand. So all evaluation or all characteristics in coding theory should be increasing, monotonically increasing. It means that no one has a line inside. And then that is the solution number 1. I think it's enough to understand how can we save the energy. Then the second is cooperative communication. It's actually inspired from the turbo code. So by the channel is broadcast nature. So in the past, for example, I sent message from here actually to Mr. Aryo, but my signal will go to everywhere. But in the past, you don't care. The person who cares is Mr. Aryo only. But in the future, you should use my signal. Yeah, from here, so you catch and then you transfer to him. It means that you help me. Right? And then, what is the reward of me? Maybe in the next day, you need to transfer to him, and then I also catch your signal, and then I transfer to him. So this is what we should use in the future. So this will be a new potential resources in the future. Yeah. The broadcast nature, long considered a significant waste of energy, causing interference to others, is now regarded as the potential resources. So if you are here and then you want to transmit to him, so your friend help you. So this is the key of future ICT. So don't waste energy, and then things in the positive way. If you help your friend, and then on the other day, your friend will help you. Then, the next, this is the solution number 3. We need new techniques and also new paradigm. New techniques and new paradigm. Nowadays, we are also using MIMO. MIMO means multiple input, multiple output. So you have antenna, many antenna at transmitter and many antenna at receivers. But in the future, even though that you don't have many antennas, if you don't have many antennas, and then by considering that everybody will have, and then your friend can be regarded as the antenna for you. The antenna for you, such as you can improve the performance. So this is also what we do. This is our result, and then it is accepted in IEEE PTC Spring in Yokohama. This May, I will make a presentation on this in Yokohama. So if you are interested, so please come to Yokohama for this. Actually, the idea for this is very easy. For example, if you are here, you transmit 1, and then your friend transmit -1. But what you receive here is 0. And then what you can decide from 0? Nothing. But this will be the last quiz. To solve this problem, I will show in the last quiz. Okay? I think this is not so important. Okay. Quiz number 3.
Okay, so this is special for married couple. No, right?
Okay. Suppose that we have 3 married couples, and then couple A, couple B, and couple C. Which one of the following couple does not need communication? Or you want to ask me what is communication? No. Assume that no information from other relative or friend. Because if you can get information from friend, and then your decision will be different. This is similar as the probability of Y given X. Couple A with probability of love is 0.15, and probability of love equal to no, your husband or your wife does not love you, is 0.85. And couple B, probability of love and unlove is the same, 0.5. And couple C, probability of love and not love is 0.95 and 0.05. And then given the following 3 hints. This is what we learned from the first quiz. And then the mutual information. This is the information. Actually, the capacity is divided by this, equal to the entropy of love minus the entropy of love. Given, actually the color here is red, but I don't know. The color is red. So if you receive information from your colleague that he or she loves you, this will be not 0. For example, if you want to know that your wife or your husband love you or not, and then you ask his or her friend. If your friend tells you about your wife or your husband, and then it means that mutual information will decrease. Okay, given this, and then love. Actually, this is the red love. Is to receive knowledge from other relative or friend.